Mungu ibariki Tanzania, dumisha uhuru na umoja wake kwa waume na watoto. Mungu ibariki Tanzania na watu wake. Ibariki Tanzania, ibariki Tanzania, tubariki watoto wa Tanzania.
Are you looking an online institution where you can learn, understand, enjoy, and apply the beauty of higher engineering scientific mathematics? Possibly that might be one of the questions that you've been asking yourself for a long time. How are you, everybody who is watching this video? I would like to take this opportunity to welcome all the national and international viewers who have joined into this fantastic program. My name is Olenjolain, Moko TAYAI Losingo. Simply just call me Olenjolain. I thank God by His own grace that I'm a Tanzanian and this is our national flag. And I would like to welcome you into these fantastic programs where we are going to pour out what we know about higher engineering and scientific mathematics for engineers. I thank God by His own grace, He built in me His gift of being a national and international teacher who is teaching mathematics, science, engineering, and computer programming. I thank God also by His own grace that He has built in me His gift of being an engineer. Professionally, means that formally I'm electronics and telecommunication engineer. I'm a graduate in electronics and telecommunication engineering. And also informally, I'm electrical engineer and a computer scientist. When I say electrical engineer, I mean about four field. But anyway, that's not the great case for you. The issue is you are suffering from different challenges that you're encountering in your process or in your journey of learning the beauty of higher engineering and scientific mathematics. Possibly you who is watching these programs, or maybe you know somebody who is interested or who can benefit in this program, you are asking yourself so many questions how you can learn and master higher engineering and scientific mathematics. These programs is well prepared and dedicated to all undergraduate students who are doing different programs in engineering and science. I would like to take this opportunity firstly to welcome you, all our national and international viewers, into one of our online institutions that called Online Undergraduate Polytechnic Institute of Tanzania in square bracket Olenjolain. Simultaneously, currently, we are sharing our contents in the national level and international level through one of our official YouTube channel that called Online Undergrad, abbreviations of undergraduate, POLYINSTIT, these the abbreviations and combinations of the two ways Polytechnic Institute of Tanzania in square bracket Olenjolain. By using that official YouTube channel, it means you can search that channel and you can access all the contents that we have. You may be asking yourself so many questions, what are we doing in OPITO? Because abbreviations of OPITO, the long terms of OPITO stand for Online Undergraduate Polytechnic Institute of Tanzania, square bracket Olenjolain. So what vision we have? That might be one of your questions. Wonderful. That's a very fantastic question. We have an assignment to teach and train undergraduate students on how they can extract knowledge, understanding, and wisdom from fundamental and core program courses or modules, and combine it with knowledge, understanding, and wisdom that you are going to teach them to extract it from the Word of God written in the Holy Bible in order to solve real-life problems. Remember that this is a special YouTube channel to train and teaching undergraduate students. So all the contents will be proportional. All the contents that you are going to create will be proportional and benefit firstly undergraduate students. However, that some other students also they can find some applicable concepts. What problems are we solving? Well, according to my research, when I was a student in undergraduate level in electronics and in bachelor in electronics and telecommunication engineering at the Islam Institute of Technology, I discovered that many undergraduate students who are pursuing engineering programs and science programs are facing so many challenges in learning, understanding, enjoying, and applying higher engineering mathematics and higher scientific mathematics. So I've been solving that problems locally, but thank God by His own grace, right now, He just took my concepts or my solution in the national and international level. So remember that undergraduate higher engineering mathematics and undergraduate higher scientific mathematics is cross-cutting modules or cross-cutting courses that are covered by undergraduate students in any country, in any continent across the world. So we say this will be multinational concepts. The difference is just some minor contents. Again, I would like just to welcome you and just to give you some few steps that you have to follow for you to register yourself permanently into OSO. The first step, if you have an email, then you can skip the first step. This registrations to OPITO. OPITO is abbreviations of Online Undergraduate Polytechnic Institute of Tanzania. So the first step, if you don't have an email, you can create or open a new email. A new email address. The second step, if you don't have a YouTube applications system broadcasting application software, then you have downloaded it. Once you have it, then we ask you to sign in YouTube, and you can only sign in YouTube by using your email. And when you're using your email, you have to remember your password and username. The third step, we ask you to search it. We ask you to search OPITO. Don't write OPITO because it's not there, but just search it. Test this official YouTube name, Online Undergrad Institute of Tanzania in square bracket Olenjolain. So search for OPITO, not in YouTube. Once you search it, you'll see our poster, which contains, means that the software round buttons, which contain Tanzania national flag. Here you see the number of video, you see the names, OPITO, but it's abbreviations, Online Undergraduate Institute of Tanzania in square bracket Olenjolain. You see the number of videos, you see the number of subscribers, etc. So the third step, the fourth step, you see a round buttons with our national flag. This is our national flag, right? So we ask you to click it. Click round button. Okay, click the round button. Click the round button. Once you click the round button, so you see the horizontal toolbar, which is written homes, videos, playlist, and then you will see community, channels, and what about. Very important horizontal toolbar. The first step, we ask you to click the buttons which has a red background and white text, which is written so to subscribe. Subscribe. So once you click it, the text will change into subscribe. And then the icon of the bell will appear. Click the icons of the bell, then you see options of what of all. From there, you have already registered yourself permanently and you can access our contents at any time. And we ask you to visit it regularly and every day in this official YouTube channel, because we are adding new contents every day, every week, every month. So make sure that you should be an active students. By doing so, in case you are online, you will receive the notifications once we add a new video. So make sure that it is the learning place for you at any time and anywhere. So also you can take advantage of what using the playlist, how you can access our contents. We used to create a playlist for each topic and we used to create also a playlist for each module. For example, in the modules that we are going to learn today, which is called Advanced Calculus, which comprises 4 topics, about the syllabus of NACTE, and especially the syllabus used at the Dar es Salaam Institute of Technology. It contains 4 topics, right? So the first one is called Gamma and Beta functions. That's what we are going to teach. So we have created playlist for Gamma and Beta functions. So you can go into that playlist and you'll see all the lectures about Gamma and Beta function. Thank you very much for registering yourself permanently. You can also share the contents, these contents, through the social media to some of your colleagues. So, again, I'd like to take this opportunity to welcome you into departments of higher engineering and scientific mathematics. It's one of the departments that we have in our online institution. The subject of the day is called the Advanced Calculus, and this is called subject of module. And then this contents is for the first or second year Bachelor in Engineering, Bachelor Engineering programs or Bachelor in Science. So this is Bachelor in Engineering, Bachelor in Science, or at Dar es Salaam Institute of Technology, or under the curriculums of NACTE in the United Republic of Tanzania, we call it NTA, National Technical Award Level 7. All right. So we are in lecture 7, that's titled Applications of Gamma Function. This will be the last lecture about gamma. The next lecture, which will be lecture 8, I'm going to teach you about beta function, because I've never talked about beta function. I believe that you're enjoying our contents, so let us go into the business. So to start our today's lecture, which is lecture 7, let us do a quick review. Quick review of what? Quick review of lecture 6. In lecture 6, we told you about gamma table, right? And what did we say? If you do remember that, we say we use gamma table, right? So we say gamma table is used to evaluate gamma function. It's used to evaluate gamma function of what? Of a number. Used to evaluate gamma function of a number. So for example, we discussed the gamma table of 1 less than or equal to x less than or equal to 1. Oh, excuse me. Yes, less than or equal to 2, if you do remember. So you've been given, so if you do remember that we say the horizontal is the second decimal place, and then the first row, and the first column representing what? The value. Then we have the second row, third row, fourth row, etc. This representing what? So it means that the number. So this representing number in 1 decimal place, right? But this one also representing what? Gamma function. Representing what? Gamma function. So that's what we have been discussing. And then we used also the property that we call the gamma of n plus 1 is equal to n gamma of n. But we didn't use directly, we used this one. Gamma of n is equal to gamma of n plus 1 over n. Okay? So today we are teaching you about applications of gamma function. What are the applications of gamma functions? Where do we use? Why are we learning and bothering you to learn different concepts of gamma function? So today you'll see some of applications of gamma function. So ladies and gentlemen, let us introduce, let us get inside lecture 7, and let me teach about applications of what? Applications of gamma function. Bear with me, applications of gamma functions. So let me start with a sentence. I have We are going to solve 4 problems and the answer will give you 1. And 2, 5, I think that's 5 problems, yes. Example 16, 17, 18, 19, yeah. 4 problems. And 2 problems are conceptual. So this is the sentence that I would like to make. We say that gamma functions are used to evaluate. So these gamma functions are used to evaluate the finite intervals So it's used to evaluate the finite intervals depending largely on the ability of the student, ability to change the variables, the given variable, because it is a single variable, to change the given variable into the standard basic form of integral formula of gamma function. So we use gamma functions to evaluate the finite intervals, depending largely on the ability to change the given variable into the ability to change the given variable into the standard form of integral formula of gamma function. So this is the sentence that I wanted to make. So gamma function can be used to evaluate the finite intervals, but not simple as the way you think. Some of the problems that we are going to deal with will be given in a certain form. So we have to use the concepts of gamma, or we have to use the different concepts of mathematics, we call it just the ordinary mathematics, to change the given expressions or the given equation into the standard form of integral formula of gamma function. What does it mean? So recall, we taught you in lecture 1 that gamma function of n, this is equal to the integral from 0 to infinity. Then you have e power negative x power n minus 1 dx. This is the formula that you are going to use with combinations of what? Of properties of gamma. Right? So this is the integral formula of gamma function. So remember about this one. And whenever you find a question in advanced calculus that has the finite integral in which the upper limit is infinite, then you have to remember about 30. You have to remember about gamma function, because it is the only function that expressing the finite integrals as a limit from 0 to infinity. So this is a very important sign for you to solve and deal with different problems that will be given in different contexts. All right? So that's the concept. So simply say that the gamma, so the definite integrals, okay, different integrals, the definite what improper integrals of what? The definite integrals of lower limit of 0 and the upper limit of infinite are evaluated by using integral formula of gamma function, and what? And the integral formulas of gamma function, properties of what? Of gamma function, and what? And the derivative of the single variable. So basically, when we be solving these definite integrals, or we call this definite improper integrals, we'll be using the integral formula of gamma function, which is this one, and also be using properties of gamma function, and be using derivative of what? Of a single independent variable, or single independent variable. However, that will be starting with what? Derivatives of the single variable, then we come back into the properties, and finally we get the gamma function of the given problem. Okay, so we are mathematicians, so we say that, not this. If the given integral, if the given definite integral is not in the form of what? Of gamma function of n, which is equal to 0 to infinite, e power negative x power a minus 1 dx. So if the given definite integral is not in the form of that, is not in the form of this, so I say that then simplify the given expression. Simplify the given expression. Okay? Simplify the given expression till it is equivalent to gamma of u, for instance, is equal to integral from 0 to infinity, e power negative u, then we have what? U power so it's a gamma of n. So here you have e power negative, e power negative u, and there you have u n minus 1 du. So I have prepared some examples to illustrate that concept, but not before. So ladies and gentlemen, let's now solve those problems of 14 the finite intervals. In case you have any question about applications of gamma function, don't hesitate to ask in the comment sections of this video. Alright? Make sure to use the comment section to ask any question about what I'm teaching. I left the homework 5, homework 6. Yes, I left the homework 6, which was example 15, which was very interesting. I believe that everything is going well. So let today introduce to you, ladies and gentlemen, example 16. In this example 16, you have to refer high engineering and scientific mathematics books that called the advanced, refer a book called Advanced in Maths by what? By Stroud. Okay, Advanced Mathematics by Stroud. Well, it's called the Engineering Mathematics, not Advanced Mathematics, excuse me. It's called the Engineering Mathematics by Stroud. So the question states that evaluate the integral from 0 to infinity of x power 7 e power negative x dx. That's the problem. It's a definite integral where limits are varying from 0 to infinity. Then the integrand is what? It's a product between the natural exponential function and common exponential function. So you have to evaluate. Ladies and gentlemen, you should not confuse with this problem. Remember, the first step. So the first step, whenever you want to solve these problems, we say that we call the integral. So we call the integral formula of gamma function of n. So this one is a gamma function of n is equal to integral from 0 to infinity e power negative x, then x to power n minus 1 dx. Is the standard formula. So how about the limits? The limits are from 0 to infinity. Then check, also compare the exponent. Okay, so the exponents is okay. So you can compare the natural exponential. So we go for the second step. So the second step we say that compare. So suppose that this is equation 1. So compare equation 1 with what? With the given expression, which is 0 to infinity. Then we say that x power 7 e power negative x dx. So after comparison, we will find that e power negative x is equal to e power negative x. So it will cancel. Then also you'll find that integral from 0 to infinity, this is equal to integral from 0 to infinity. But you'll find that x power n minus 1 is equal to x power 7. Do you understand? In case that you don't understand, don't hesitate to ask your questions in the comment section. Simply say that compare Okay, so let me repeat and clarify this one. We say that we have this expression, gamma of n is equal to integral from 0 to infinity e power negative x power n minus 1 dx. This is first equation. And then so be given an expression that we have to evaluate, integral from 0 to infinity. Then you have e power negative x power 7 dx. So this is so you say that this is what? So this is the expression 2. So you say let us compare expression 1 with what? With the given expression. So, but let us compare it. The right hand side. Let's compare right hand side of equation 1. So if you compare, we find that integral from 0 to infinity e power negative x power n minus 1 dx. This is equal to integral from 0 to infinity. Then have what? E power negative x, then x power 7 dx. So you find that this integral and this integral will cancel. Dx and dx will cancel. E power negative x and e power negative x cancel. So you find that x power n minus 1 is equal to x power 7. So we go for the third step. So the third step, we say that base. So suppose that this is equation 3. So say that base of equation 3 is the same. So if it's the same, we can cancel the base and remain with indices, which is n minus 1 is equal to 7. So make n the subject. So n is equal to 7 plus 1, which is equal to 8. Okay? It's equal to 8. So you got the fourth step. So you say substitute n is equal to 8 in equation 1. In the left hand side of equation 1. So this is gamma of n, but n is equal to 8. So you're looking gamma of 14, gamma of 8. And ladies and gentlemen, we have to recall, or we have to go into the last step before we conclude or we get the value of the given definite interval. So the fifth step says that we have to recall the property of gamma. Gamma of n plus 1 is equal to n factorial. This is the second property, n factorial. So if that's the case, gamma of 8, this is equal to gamma of 7 plus 1. Right? So value of n is what? So if you compare, n is equal to 7. So it means that this is equal to 7 what? Factorial. So you may use your scientific calculator to find to find 7 factorial. So it's 5,040. 5,040. So ladies and gentlemen, the response or the value of integral from 0 to infinity of e power negative x power 7 dx. This is equal to 5,040. At the final response. So that was a breakfast example. Very simple example. Example 17. This you have to refer the entire tutorial sheet, question what? Question 2, Roman 3. Don't worry if you don't have the tutorial sheet. Don't worry, I'm going to write a question on the black, but in case you have it, you can check. And this is solution for exercise 1. So remember that this one That question you will find in exercise 1. There are 4 exercises of tutorial sheet for this module. Okay, how the questions read. You are given a challenge. Evaluate integral from 0 to infinity e power negative x power negative 2 x squared dx. Are the questions you have to evaluate. Solution. You may pause the video and try to solve this question yourself. Solution. So you say this. Say gamma of n. No. You say that the first step always recall standard integral form of what? Of gamma function. And this has 2 parts. The left hand side gamma of n is equal to integral from 0 to infinity e power negative x power n minus 1 dx. I believe you're enjoying the beauty of higher engineering and scientific mathematics. Okay, so here we have gamma of n is equal to integral from 0 to infinity. Then we have e power negative x from 0 to infinity e power negative x power n minus 1 dx. Okay? Okay, fine. So suppose that this is the first equation. So if you try to compare, right? If you try to compare, so I want to show you the challenge. So the second step, so this is the challenge. Now what the challenge? It means that if you compare integral from 0 to infinity x power n minus 1 e power negative x dx, this always will be unequal to integral from 0 to infinity, then what? Will be given e power negative twice x squared, and then, oh, excuse me, I made a mistake. This is x squared. Here you have x squared. E power negative 2x squared. So you have x squared, e power negative 2x squared. E power negative 2. So x squared, e power negative 2x squared. So e power negative 2x squared, then you have x squared dx. Why these two expressions are not equal? Because, so remember that the reasons. E power negative x is not equal to e power negative twice x. So I told you that in case the given expression or the given equation, the given expression, the gamma, in case the definite integral expression, which is given, is not in the standard form of gamma function, then express it in gamma function first. So if that the case, we go at, so that the challenge, we go into the third step. How can we deal with these problems? So the third step, we say that express the given integral, the given definite integral, which is integral from 0 to infinity, x squared e power negative twice x squared dx. You have to express it in standard form. in standard integral form of what? Of gamma function. How? We have to let u is equal to 2x squared, because the only thing is coefficient and also the variable, because we have to make sure that we change e power negative 2x squared into e power negative a certain variable. So that's why we say the step, we have to let u is equal to 2x, and then from there we have to do it to eliminate, to change what? To change the variable. To change what? Variable. Variable from what? From x to what? To u. In our process of changing this variable from x to u, then we'll find that we'll simplify the integrand of the integration. So once we let this one, we say that we want to eliminate what? So in the given expression, we have dx. In positions of 2x squared, we are going to place with u. So to replace x, we have to differentiate that equation. U is equal to what? 2x squared. So let us differentiate. So differentiate respective to x. d dx of u. This is equal to d dx of twice x squared. That is the principle of power. So here we have 2 times what? Times 2 x power 2 minus 1. So du dx is equal to what? Is equal to 4 x power 1. So x power 1. So say that's fine. Let us make the x the subject. So to make the dx the subject, we say that let us multiply by dx into both sides. So this dx and dx cancel. So we find that on the left hand side you have du is equal to 4x dx. So then we say that we have u is equal to 4x dx. So let us make for our dx the subject. So divide by 4x divide by 4x. So this will make dx is equal to du over 4x. Okay, 4x. So this will make your the second equation. But remember, we say we let u is equal to twice x squared over 2, and this one divided by 2. So here you have u over 2 is equal to x squared. Then you have to under root. Once we under root, we find that x is equal to under root of what? Of u over 2. Simply, we say that this is equal to what? Under root of u over under root of 2. Because we need, we say that this is u in exponential form power half over square root of 2. So we say x is equal to what? U power a half over under root of 2. So this is equation 3. So let us substitute equation 3 in equation 2. So that will be what? The first step. We substitute equation 3. So substitute equation 3 into equation 2. Okay, into equation 2. Okay, so to substitute there, we had dx is equal to du over 4x. For that case, this is equal to du, then 4, for the value of x. Value of x, it's u power half over under root of 2. So then we say that what dx is equal to du of what? So here we have under root of 2 in numerator, then over 4 u power half. In other way, this is equal to under root of 2 over 4. Then we have what? 1 over u power half du. We are still simplifying. Dx is equal to under root of 2 over 4. Then we have what? Times u power negative half. Then what? Du. So this will be what? Equation 4. So equation 4, what are we given? So remember the given expression is what? So I say that we go for the fifth step. The fifth step, we say that substitute equation 4 substitute equation 4 into the expression integral from 0 to infinity e power negative trace x square. Then here we have what? X square dx. So remember also you have what? Okay. So substitute equation 4. Let us substitute equation 4 and equation 3 into the given expression. So we are changing the variable from x into u. So if you change the variable, you don't need to change the limits because the limit will be the same regardless of whether the variable is changed or not for this case. Then we have integral from 0 to infinity e power negative u, because we let u is equal to twice x squared. Then we have x squared. What is x squared? So I have to substitute equation 3. X squared is what? It's u power half. It's u power half over under root of 2. Then times 30. Here times dx. What is dx? Dx is under root of 2 over 4. Then have u power negative half du. Alright? So you can simplify there. U power half times u power negative half. Products of the exponent of the same base, we add the exponent. So a half minus a half, or a half plus a negative a half, it's 0. So this expression will be integral from 0 to infinity e power negative u. Then you have what? U power 0, because you want to see it. And then here we have what? Multiplied by what? Under root of 2 over 4. Then du. So simply this is equal to what? Take under root of 2 over 4 out of integral, and then we are integrating from 0 to infinity e power negative u du. excuse me, here we forgot we have x squared. So if there we have x squared, then this entire expression is wrong. Okay. So if you square it, get u. And then we have what? I'm looking for okay. So if we square this, we get here, this is equal to integral from 0 to infinity e power negative u power half times 2, so we multiply the exponents, so half times 2 it is 1, so you get u power 1. Then we have what? Under root of 2, we take it out of the integral, so we have under root of 2 of what? Under root of 2 square, it is 2 times 4, it's 8. So here you have u power t power 1. Then multiply by what? Multiply by u power negative half du. So this will make what? This will make under root of 2 over 8 integral from 0 to infinity e power negative u in standard form. And then you have what? U power 1 times u power negative half. This will make u power half du. Remember that the given expression is in variable x, but when we are simplifying the expression, we had intermediate variable, which we call u. But later on, we have to make sure that our final response will be in the variable, with the independent variable x. So here we have what? We have under root of 2 of what? Over 8 integral from 0 to infinity e power negative u, then times what? U power a half, u power what? U power a half du. Right? Okay. So this is one of the expressions. So we say that we'll be dealing with integral from 0 to infinity e power negative 2x squared. Then here we have x squared dx, not du, dx. This one now we have expressed in form of u, where we have the same limits. There's no need to change the limits because the limit will be the same. So here we have a power negative u, then you have u power half, then d. So suppose that this will be what? Equation 5. So we go for the sixth system. Right now, the right hand side of equation 5 is the same to the standard integral formula of gamma function. So we say that now we can compare right hand side of what? Of equation 5 with what? With the standard formula, which is what? So which is integral from 0 to infinity e power negative u power n minus 1 dot du. So if you compare, you will have what? U power n minus 1 is equal to u power half. Same base, compare what? Exponent. So same base, compare exponent. So here you have n minus 1 is equal to a half. Make n the subject. So n minus 1 plus 1 is equal to a half plus 1. So n minus 1 plus 1 is equal to n. And a half plus 1, this is equal to 3 over 2. Remember that we are evaluating the finite integrals by using properties of gamma and the integral formula of gamma. So we go for the seventh step. Write that questions as a conceptual question. So the seventh step, we say that substitute n is equal to 3 over 2 into left hand side of what? Of equation 5. So to substitute it on left hand side, we have gamma of n is equal to what? The gamma value of 40 of n. So it's what? It is 3 over 2. And we told you, this is the standard. So it's what? So simply this is equal to a half, gamma of a half. So this is under 2 over 2. Alright? So under 2 over 2. So if that's the case now, say what? Okay, fine. So we had it. Remember that here we had what we dealt with only this part. We left this one. So for that case now we say that integral from 0 to infinity of e power negative twice x squared dx. This is equal to, this is equal to under root of 2 over what? Over 8 multiplied by what? Gamma of n, which is gamma of 3 over 2. So multiplied by gamma of n, and this will make what? So gamma of n, which in this case is gamma of 3 over 2. For that case, this is under 2 over 8 times what? Under 2 over 2. So this will make your thing. Excuse me. Gamma of a half, it is under 5. Excuse me for this mistake. Gamma of a half, it's what? Under pi, not under 2. So here we have under 2 times what? Under pi over 2. Right? So therefore, the final response for this conceptual question, if you integrate it from 0 to infinity, e power negative what? E power negative twice x squared dx. The response is equal to what? Under pi times under 2. The answer is under 2 pi. Then 8 times 2, it's what? It's 16. At the response. So that is how we solve conceptual definite improper intervals by using gamma function. By using gamma function. Okay. So now let me teach you another example. This is example 17. Example 17, it states that I took also from what? From the engineering mathematics by Stroud. So the question states that evaluate integral from 0 to infinity of what? Of x cubed e power negative 4x dx. That's the question. You can pause the video and try to evaluate that integral yourself. Because
You have to test it yourself if you've understood the concept which I've been teaching you.
Okay, so this is the problem. So you have to inspect it. If you inspect it, you'll find that integral from 0 to infinity, then you have what? E power negative 4x, then you have x cubed dx. From that expression, you will find that if you recall the integral formula of what the gamma function, here you have e power negative x, we have e power negative x, and then on this side we have what? X power n minus 1. So the first step, the first step, we say that what? Inspecting given what? Given interval. So inspect the given interval. So when you inspect the given interval, we find that e power negative x is not equal to e, or is not equivalent to e power negative 4x. So you have to simplify, right? So we go for the second step. If that's the case, we say that let us simplify the given expression, the given interval, which is integral from 0 to infinity. We had e power negative 4x, x cubed dx. How do you simplify? Wonderful. I told you, you follow the same procedures as how I taught you, in lecture, in example 16, right? So you say that let u, or any other variable, let u is equal to 4x. So when you have to make sure that whenever you find the indices or the index of e is not negative x, then you have to let the positive part of expression of a number. So that's why we say let u is equal to 4x. Latents means we are changing the variables. So remember that with this process, we are changing what? We are changing variables. We are changing x into u. But remember that we have just to change x, or the variable x in the given equation, into u, and the derivative of that integral expression. But remember that we won't deal with what? We won't deal with limits, because the lower limit when the integrand is in variable x is the same with the lower limit when the integrand is u. So you have let u is equal to 4x. So we differentiate u with respect to x. This is equal to 4. What does it mean? If you differentiate d dx of 4x, simply this is 4. So the u is equal to 4 dx. Make the x the subject. So divided by 4, divided by 4. The x is equal to the u over 4. The u over t over 4. Okay? So if that's the case, we say this is first equation. Again, if you inspect the given expressions, we have x. It means we eliminate the derivative of this integral, which is x, with these expressions on right hand side, the u over 4. Right? Again, we have to come back into what we've let. We've let u is equal to 4x. Make x the subject. Divide by 4. So whenever we find x in the given expression is equal to u over 4. So this one is the second expression. Okay? It's the second expression.
So we go for the third step. The third step, we say that let us substitute equation 1 and 2 into given integral. So the given integral is what? Integral from 0 to infinity e power negative 4x, then x cubed dx. So if you substitute, we have integral from 0 to infinity, then you have e power negative u, because x is equal to, let u is equal to x, is equal to 4x. So u is equal to 4x. Then you have what? X cubed. What the value of x cubed? So x cubed, it's u over 4 power 3. It's u over 4 power 3. Then you have what? Dx. What the expressions for dx is du over 4. So this is a process that you have to follow. Du over what? Over 4. So in this process, you'll find that the integral from 0 to infinity, here you have e power negative u, here you have u cubed of what? 4 power 3 times what? Du over 4 power 1. So we say this is equal to integral from 0 to infinity e power negative u, then you have what? U cubed divided by what? 4, same base, 4 power 3 times 4 power 1. This is equal to 4 power 4 du. So if you keep on simplifying, here we have 1 over what? 4 power 4, then you have integral from 0 to infinity, and then say what? E power negative u, u power 3 du. Okay. So then where are we looking for? We are looking integral from what? 0 to infinity e power negative 4x x cubed dx. This is equal to 1 over 4 power 4. 4 power 4. This makes what? 128. 4 power 4. Wait. 4 times 4 is 16. And then 4 times 4 is 16. So 16 times 16. This is 61. That is 6, 9. So 6. So 256. So this is equal to 1 over 256. Then we have what? Integral from 0 to infinity of e power negative u. Then we have u power 3 du. Okay? So we go for the first step. First step, we say that compare standard or compare integral from 0 to infinity e power negative u, u cubed du with what? With standard integral formula of what? Of gamma of n, where we say that gamma of n is equal to integral from 0 to infinity, then e power negative x, then x power n minus 1 dx. Just you have x, but there we have variable u, so you have to change the variables. So we can compare with e power negative u. So you see that now the two natural exponential functions are the same, and hence you have u power n minus 1 times what du. So if we compare, you'll find u power n minus 1 is equal to u power 3. So these are exponential expressions on left hand side and right hand side of the same base. So we cancel base and then we equate to exponent. So n minus 1 is equal to 3. So n minus 1 plus 1 is equal to 3 plus 1. So simply n is equal to 4. N is equal to what? N is equal to 4. So if n is equal to 4, then we go back. So we go for the fifth step. So the fifth step, we say that we are looking integral from 0 to infinity of e power negative 4x. Then here we have what? X cubic dx. And this one is equal to what? 1 over 256. And then here we have gamma of n, for the value of n is 4. Okay? So to find gamma of 4, you have to recall the second property of gamma function. But gamma of n plus 1 is always equal to n factorial. So for that case, we say that integral from 0 to infinity e power negative 4x x cubed dx is equal to what? Is equal to 1 over 256 gamma of n, where n is 4, and gamma of 4 is equal to gamma of 3 plus 1, which is equal to 3 factorial. So this one we say that in short, 3 factorial. 3 factorial is 6 over 256. So if you simplify, say that this is integral from 0 to infinity, then e power negative 4x x cubed dx. So by 2, 128, and there by 2, you have 3. So you can simplify by 2, 3, and by 2, 128. So that the final response for the given infinite improper integral. That is how we solve gamma function problems. Do you want again an extra example? If the answer is yes, tell me in the comment section, please. You enjoying this content from which institution? Enjoying this content from which continent? Enjoying this content from which country? Tell me in the comment section, please. Interact with me and ask your questions in the comment sections as well as you can. Okay, that's all about 30. Example 17. Let us go to example 18. So by using the concept that I taught you in example 17 and example 16, now you can solve different problems of what? Of gamma function. Alright? So let us check this example 18. You have to refer the IT tutorial sheet. The IT tutorial sheet. You have to refer the IT tutorial sheet. Exercise 1. Exercise 1. Question 2, Roman 4. Question 2, Roman 4. The question states that evaluate the integral from 0 to infinity of x power 1 over 4. Here you have what? E power negative under root of x dx. So this is concept question. You have to deal with such kind of the problems.
So, ladies and gentlemen of undergraduate level who are doing different programs in engineering or science, you can pause the video and try to solve that questions yourself. So take it as a quiz. So you can write this question as what? As a quiz. So take it as quiz what? Quiz number 7. Try it. Pause the video, try that questions. Evaluate that integral. Follow the same procedures as I taught you in example 16 and follow the same procedures I taught you in example 17. This should not worry you. It's normal. It's how we've dealt with in other aspects. Thank you for trying. Congratulations. Let us do correction. Solution. Okay, so the first step, we got inspect. Inspect what? The given expression. It's integral from 0 to infinity, x power 1 over 4, e power negative under root of x dx. Okay? So the first step. So the second step, before the second step, so when we do our inspection, we find that simply find that e power negative x from the standard integral formula of gamma function is not equal to what will be given. It's not equal to e power negative under root x. Remember that always we don't have any problems with x. We have problems with what the index of e. Because the index of e of any given expression should be the same with the index of the standard integral formula of gamma function. So if that's the case, you have to simplify first. So second step, you have to say that you have to simplify what? You have to simplify the given expression, which is integral from 0 to infinity. Then you have what? X power 1 over 4. Then you have what? E power negative under root of x dx. Alright? So if that's the case, we say that the problem there is not the negative sign. The problem is what? Under root of x. So say let u is equal to under root of x. Simply, in other words,
under root of x is equal to x power half. So to let u is equal to what? Under root of x or x power half, this can make the first equation. Then we have to eliminate what? So when we let this one, we have to change the variable x, every variable of x in a given expression, into a variable u, or into any letter. It's not necessary to be u. It can be p, it can be q, it depends on your choice. But choose the standard letters used in mathematics. So we say du dx, let us differentiate equation 1 with respect to x. This will make it a half x power half minus 1. Wonderful. So this will make it 1 over 2 x power negative a half. Yes, because it's a half, okay, power negative a half. In other way, du dx is equal to what? Is equal to 1 over 2 under root of x. Okay? But remember, we say that under root of x is equal to u. So du dx is equal to 1 over 2u. Make the x the subject. So if you cross multiplication, we will find that dx is equal to twice u du. So this will make it the second equation. Second expression. So you know the dx will be substituting the dx with this expression on right hand side, and be substituting what? So we have also x in a given expression. How can we simplify x, or how can we change this x into u? So remember the principle. We say that we have let u is equal to under root of x, and this is x power half. So we have u is equal to, let's say, under root of x, so you can square both sides. So if you square both sides, you find u square is equal to x. So this will make it the third equation. Okay? That will make the third equation. So we know what is dx, it's equation 2. We know what the value of x is, equation 3. We know what the value of of under root x in terms of u, it's u. So you go for for the third step. The third step, say, ladies and gentlemen, let us substitute equation 2 and 3 into the given into the given expression. Into the given expression. Into integral from 0 to infinity x power 1 over 4 e power negative under root x dx. So if that the case, you say that this is integral from 0 to infinity, then you have x. What is x? X, it is what? U square power 1 over 4. Then you have what? E power negative what? Power negative under root x. So power negative u du. So ladies and gentlemen, we say that this is what? Integral from 0 to infinity. Then you have what? U square times 1 over 4. Then you have e power negative u du. So this one, we say that it's integral from 0 to infinity. We have what? U power a half and e power negative u du. So we have expressed the given expressions in terms of what are the functions of what of u. Wonderful. So we have that ones. So you go for the first step. So compare what? Compare the new expression as of integral from 0 to infinity, u power half e power negative u du with what? The standard integral. The standard what? The standard integral integral gamma function. Okay? You can check how. You can check what did you get or how have you solved this problem in a triad. So if we compare, then we find that u, because remember that the standard integral is gamma of n, this is integral from what? From 0 to infinity, e power negative u, and then have u power n minus 1 du. Okay? So we are looking for the whole of n. So if you compare, you find that u power n minus 1 is equal to u power half. U power half. So these are the two exponential expressions of the same base. So you have to cancel the base and compare it and compare the exponent. So this will make the base over 2. Okay? So if that's the case, the good thing that we don't have any coefficient outside of 40, outside of bracket. Do we have any coefficient there? Any coefficient, ladies and gentlemen? It's not there. Okay. 3 over 2. So you have to find gamma of 3 over 2. But wait. dx it is 2u du. Excuse me, let me do minor correction. dx, when substituted dx, it's 2u du here. It is 2u du. So this one is 2 u power this one, and then say what? Also we have u power 1. Excuse me, u power 1 du. So if we simplify, this is equal to 2, because 2 is constant, u power half times u power half times u power 1 is equal to u power 3 over 2. So here, it's not your half. It's what compare 2, or compare this one, we sort u over 2. So if we compare here, this is u power 3 over 2. So if we cancel, we get that n minus 1 is equal to 3 over 2. And this will make it the value of n is 5/2. So then, remember that you're being asked to find integral from 0 to infinity of what? Of x to the power 1/4 e power negative under root of x dx is equal to twice gamma of n, which is gamma of 5/2. And I told you, it's very simple for my students to find gamma of 5/2. So it's integral from 0 to infinity, x power 1/4 e power negative under root of x dx. This is equal to twice, so times what? 3/2 gamma 3/2, so 3/2 multiplied by what? Gamma of 1/2/2. So this will make what? This will make integral from 0 to infinity of x to the power 1/4 e power negative under root of x dx is equal to what? 2 and 2 cancel. Gamma of 1/2 is under root of pi, so this is 3 under root of pi over 2. So this is the response for that question.
Ladies and gentlemen, before I end lecture 7, I would like to leave the homework for you to try the following question, which will make example 19 and example 20. So this is homework. Try this question yourself, homework, and give us feedback in the comment section. This is homework 7. So here we have what? Example 19, which is a review of what we have taught you in previous lectures. So example 19, this also you have to refer DIT tutorial sheet. DIT tutorial sheet, question 2, Roman 4, no Roman 7. The question asks you that evaluate. So remember, it's still not exercise 1. Evaluate the interval from 0 to infinity, which indicating it is gamma, of x power negative 3/2, then open bracket 1 minus e power negative x. Evaluate that expression. Then example 20. Example 20. This is concept. It's conceptual question. They took it from what? Refer engineering mathematics books. Okay? So the question asks you that evaluate this integral. Evaluate integral from 0 to infinity, and then you have what? 3 power negative 4 x squared dx. At the interval. So evaluate the integral from 0 to infinity of 3 power negative 4 x squared dx. So give feedback in comment section below. Okay, ladies and gentlemen, this is the end of lecture 7 and it's the end of what we have to cover about gamma function itself. In the next lecture, which will be lecture 8, I will introduce to you about 20 beta functions. I will teach you the Cartesian form of beta function and the trigonometric form of beta function. And I will teach you some few properties of beta function and relationship between beta function and gamma function. So I'll like to invite you in the next lecture, which is lecture 8. And again, in case you have any questions, don't hesitate to ask in the comment section. And keep enjoying the beauty of higher engineering mathematics and higher scientific mathematics. This is Olenjolain from Tanzania. You are beautiful and actual that helpful teacher in engineering mathematics for undergraduate level. So remember that Olenjolain does not know everything about high engineering mathematics or higher scientific mathematics. I just know small portions of it, but I have a responsibility to teach others about what I know. So in case that you want to go into too much details or to learn other contents or other courses or other modules of higher engineering mathematics or higher scientific mathematics, don't hesitate to visit some other playlist, because we are teaching 12 courses or modules in these programs that actually will be the intersections of all the courses or modules being taught in different institutions, colleges and universities, United Republic of Tanzania. So we'll be focusing on the syllabus of NACTE and syllabus of TCU. So for the Tanzanians, they understand what I mean and what I'm saying. Again, another thing that we like to tell you that we would like to have an active students. So active students means that we ask you to concentrate for your advantage and try to do the questions before I do. That's the meanings of quiz. And then make sure that you do all the homeworks. Don't postpone the homework until the day when you're preparing yourself for the testing or for the final exam. Just make sure that when you finish one lecture and you understood the concept from the beginning to the end, make sure that you do all the homework. Again, in case you feel from your heart, because teaching is a work of heart. And myself, I accepted this assignment from God Himself, who is a sponsor and founder of Online Undergraduate Polytechnic Institute of Tanzania, in square bracket OLENJOLAIM. In case you feel from your heart that you want to offer your freely thanksgiving in order to support the running costs, so that more than 6 high-definition videos of undergraduate high engineering and scientific mathematics will be recorded and published and make it to the public and distributed into the entire nations of Tanzania and the entire continents of Africa and the worldwide through the power of the internet. Then you may send your freely thanksgiving through the telephone number 0759745331. The registered name is Olenjolai TAYAI. You can send your freely thanksgiving of any amount. It will receive even 50 shillings. And also, even in case you feel from your heart you want to offer more than 1 million Tanzania shillings, you're warmly welcome. And remember that God has blessing in His hand to bless everybody who is going to offer or who is going to pay for the work of God and for this truth to be distributed into the entire world. Alright? Make sure that you don't miss that opportunity. You may offer it right now in case you are not prepared. You may offer it in the next time because it's expensive to prepare one video until we publish it to you. But remember that our God is greater than the expenses that we have to spend on producing these online contents. So, my dear students, tell me in the comment section that you enjoying this content from which institution, which year of study are you? Are you the first year or second year? Are you enjoying this content in your second semester or first semester? Tell us in which institutions are you come from, which city are you living if you're in Tanzania, which university are you studying or college, and tell us which contents are you come from in the comment section. So my dear students, I would like to say this is the end of lecture 7. Get prepared to enjoy lecture 8 about better function. But remember to think outside of the class. Think how you can apply this information on solving real life problems. Think where are you going to apply this information in relations to your engineering or science program. May God bless you and keep you until we meet in the next lecture, which is lecture 8 of a better function. See you there.